In this video, I'm going to go over the additional practice problems you were provided on Friday in class. Now we're going to do this without the use of the calculator. Convert the following into vertex form. The first thing I'm going to do is I'm going to take the value that has no x and I'm going to move it to the opposite side, in this case by adding. Opposite of subtracting 2 is adding 2. And then I'm going to leave a blank spot there. Now after I do that, I'm going to recognize that in front of the x squared, the leading coefficient, whenever it's not a positive 1, I need to figure out how to factor out that value. In this case, it's 3. To do that, 3 divided by 3 is 1, drop down the x squared. Positive 18 divided by 3 is 6, drop down the x, and then we have the value here. Now, we want to take this trinomial and we want to figure out what value here allows me to factor it in a specific way. And there's a shortcut for that. We take whatever the b value is, including the sign, we always divide it by 2 and square it. That's when it's going to go into this position. So 6 divided by 2 is 3, and 3 squared is 9. But in fact, I did not just add 9 to the right. Notice 3 times 1 is 3, 3 times 6 is 18, 3 times 9. I just added a value of 27 to the right-hand side. An equation must keep the left and the right-hand sides equal. So if I added 27 to the right, I added 27 to the right, I must also add 27 to the left to keep it balanced and equal. Now on the left-hand side, y plus 29. On the right-hand side, here is the trick. We're able to quickly factor this. Instead of saying 1 times 9 is 9 and combines to give us 6, well, two numbers, and that's 3 and 3, and do all that. There's a shortcut. And the shortcut is we're going to drop down this parentheses, putting an x in front of, in this case, the plus sign. Now, this symbol is determined by whatever's in front of the b. So in this problem, it would be addition. So I drop an x in front, and I can take 6 divided by 2 and simplify it to 3. Now moving 29 to the opposite side, opposite of adding would be subtracting. This is vertex form. It is equivalent to standard form. This is standard form, this is vertex form. So let's look at our choices. And we can see that the correct answer is D as in dog. In number 2, I am asked to identify the x-intercepts. And so whenever you find an x-intercept, you are always, let's just visually think of this. When we find an x-intercept, in this case these two, and if you had to tell me where this is located, okay, this is located at 2.5 at 0, and this is at -1 and 0. Notice that in both cases the y value is 0. Whenever we identify x-intercepts, the y value is always 0. So I'm going to take the equation that I'm provided, and I'm going to substitute 0 in for y. So 0 equals -2 times the quantity x minus 1 squared plus 6. Now to solve for x, we're going to do PEMDAS backwards. So in order to solve for x, I first ask myself, on the side that contains the x, outside of the parentheses, is there any adding or subtracting? There is. And so I'm going to get rid of the 6 first, doing the opposite operation. 0 subtract 6 is -6. Now, on the side that contains the x, is there any multiplying or dividing outside of the parentheses? There is. Opposite of multiplying by -2 is dividing by -2. And I'm going to bring this over here where I have a little more space. So I have 3 equals x subtract 1 squared. On the side that contains the variable x, is there any exponents? There is. So what is opposite of squaring? It would be the square root. Remember, that means we're going to have 2 answers. So plus or minus the square root of 3, and then I'm left with x minus 1. My very last step is now add 1, and we're going to put it in front of the plus or minus. So 1 plus or minus the square root of 3. That's an exact answer. I don't want a decimal answer unless it would be a terminating decimal. Example 2.1 or 3.4. Those are terminating. We did not round them. So let's look at our choices. And it looks like, before my computer goes off here, 1 plus or minus the square root of 3 would be option B. Let's look at at problem number 3. Which of the following has a vertex of -1, -3, and it passes through the point 5, 15. Now, I could teach you test-taking tips, but you're not going to have a multiple choice on your Unit 5 test. So let's go through how do we actually do this. So I'm going to go back up here, and I want you to write down this form. This is our vertex form. And so I'm going to start by taking the vertex, and I'm going to plug it in. So x subtract, and there's going to be some value. So I'm going to take the x value of the vertex, and I'm going to substitute it on the inside for h. And I'm going to take the k value of the vertex, and it's going to go in back. So when I simplify, I have a times, well, two negatives make a positive, and plus and minus back together becomes subtraction. Now I'm going to take the provided additional point that's on this parabola. It happens to be 5, 15. 5 is an x value. It will be substituted in for x, and 15 is a y value. Likewise, it will be substituted in for y. So 15 equals a times, I'm going to replace x with 5, and now I'm going to solve for a. So let me go through this just a little bit quicker here to save ourselves some time. 5 plus 1 is 6. I know that 6 squared is 36. I'm going to add 3 to the opposite side. 18 equals a times 36. Divide by 36, and 18 divided by 36 is equivalent to 1/2. How does that help me? I'm going to go back up to this original form. Y equals my a is 1/2. Remember that when I simplified and I plugged in the vertex, two negatives make a positive, so x plus 1. And a positive and negative back to back make a negative. So that additional point of 5/15 allows me to solve for a. This is my equation, and we can see the correct answer occurs at option A. If you were in class on Friday, I shared with you the options we have for 4. The correct answer does not exist, and so I asked students to write the correct answer off to the side. The height of a ball thrown is represented by the following equation. So let's just look and see what would this look like. Here is a person, they throw the ball, it goes up to a high point, and then it comes back down. So x is going to represent the distance the ball travels horizontally, and y represents the height. And it says the height of the ball thrown is represented by this equation. How high is the ball at the highest point? That means we want to figure out what is this maximum, and this maximum will have both an x and a y value. The x will tell us how far does it go before it hits the maximum, and the y will tell us what is that maximum height. So let's go ahead and let's do this. I'm going to write down this equation, and I know to find this point, I use the basic equation x equals negative b over 2a. Now a for this equation is negative 1/2, b is 4, and c is 1. So x equals negative, my b is 4, over 2 times a. I'm going to simplify. I end up with x equals negative 4. Half of 2 is 1, but then there's a negative, and 2 negatives make a positive. So x equals 4, but I'm not asked to find the x, I'm asked to find the y. So I know that x is 4. If I substitute it back in, I'll be able to figure out the y, and the y is the height. That's what I'm trying to achieve. What is the highest point? So let's plug in 4 here. Y equals negative 1/2, and then this would be 4 squared. I know 4 squared is 16. Then I substitute in 4 again. Well, 4 times 4 is 16, plus 1. Half of 16 is 8, and there's a negative sign, so negative 8 plus 16 plus 1. When I combine all of this, I end up with y equals 9. So the maximum height when the ball is thrown is 9 feet in the air. It's 4 feet horizontally from the player, but it's 9 feet up in the air. Correct answer for number 4. Which function goes up on the left and down on the right? So this is something you have to have memorized, so practice doing this. Take time to practice. I'm going to go ahead, and you can choose to do this however you want. So even degree and odd degree. Positive, and I'm going to abbreviate, leading coefficient, and negative leading coefficient. So the first thing I'm going to do is I'm going to write an example on each in case those new terms to you seem confusing. So y equals, we're going to go 3x to the 4th plus 4x minus 1. So the largest value as an exponent on a variable is 4. 4 is an even number, that's why it's an even. and the value in front of the variable is a positive number. So 3 is positive, degree 4 is even. What happens when this is the case? So when it's even with a leading coefficient that's positive, it's up on the right and up on the left. Now, if I slightly change that and make it -3, everything else stays the same. We still have, oh, sorry, I'm supposed to do that differently. Well, let's change that up. Let's keep that as a +3, and let's make this a 5. Let's make this a 5. So now I have an odd degree, but the leading coefficient remains positive. Odd degree, leading coefficient remains positive. Up on the right, down on the left. If we keep it with an even degree, but now this time let's change the leading coefficient to be negative. Then it's down on the left and down on the right. Now, if it's odd, so I'm going to keep this exact same equation. The only difference is I'm going to come to the leading coefficient, which is a 3, and I'm going to make it negative. So negative leading coefficient and an odd degree means it's up on the left and down on the right. So let's use that concept for number 5. Number 5 says, which one goes up on the left and up on the right? So up on the left, up on the right. Even degree, positive leading coefficient. Now sometimes they don't put them in standard form. So we can see here 5, 4, I'm looking at the actual exponents and the variables. 5, 4, 2, that's in standard form. Standard form, so these are all in standard form. On your review you were given last Tuesday, that was tricky. One of those first few problems in the first 5 asked us about end behavior, and it was not in standard form, and that did trick many of you. So in this case again, goes up on the left, up on the right. I'm looking for even degree. This is not even degree. Okay, we've got an even degree here and an even degree here. So I'm going to cross these out because these are odd degrees. 5 and 3 are odd. Now I also need the leading coefficient to be positive. This is negative, and here we have positive. Correct answer is B as in boy. All right, let's review really quickly. When we see the roots, if we're provided with a root and it's only shown once, so x equals 1, that means it's going to cut through the x-axis and it's literally going to slash straight through. It may be going up to the right, it may be going down to the right, but it's going to slash straight through. Now, if we see the roots or the solutions to an equation and we have a duplicate, so we see it twice, it's going to bounce off the x-axis, so we'll touch it and go back the same direction it came from at 1. It may come down and touch it and go back up, or it may come from the bottom and then bounce back. If we see the value 3 times, it's a cubic, it's going to snake through, and it may come from the bottom and snake up through the top, or it may come from the top and snake down to the bottom. Now when it snakes through, it's going to come up, and then when it gets to that point, it's going to level off and then go back up. So let's look at what we are provided. We are provided for number 6, and I see -4 1 time. So that means at -4 it needs to slash through. 1, 2, 3, 4, that slashes through. This could be a choice. 1, 2, 3, that slashes through. This could be a choice. 1, 2, 3, 4, it slashes through. 1, 2, 3, 4, it slashes through. So I'm not able to eliminate anything. Now 0 is written down 3 times. So at x equals 0, it needs to snake through. It does not snake through. It slashes through here. I know this cannot be the answer. It bounces off. It does not snake through. Okay, here we can see it snakes through. So I like this as an option. And here it snakes through. I like this as an option. Lastly, I see a duplicate at 3. So it should bounce off the x-axis at 3. It does not bounce off here. It slashes, it does not bounce off here. It slashes through. But we can see at 3 over here, it does bounce off. So our correct answer is option D. Okay, what are possible rational roots of the following polynomial? So in order to achieve the possible rational roots, we're going to look at the constant, the number at the very end with no x's. In this case, it's 4. And I'm going to list all of the possible factors of 4. So 1, -1, 2, -2, 4, -4. What does that mean? I can take 4, I can go 4 divided by 1, I get a nice, pretty integer answer. 4 divided by -1, integer answer. 4 divided by 2, -2, 4, -4. All produces nice integer answers. If I took 4 and divided by 3, it'd be a decimal. So that's a reason why 3 is not a factor of 4. In the denominator, I'm going to look at the leading coefficient and do the same thing. 1, -1, 3, and -3. And now I'm going to produce all of the possible choices. So I'm going to start by taking, and we can see how they do plus or minus. So 1 divided by 1 and -1 divided by 1. There we go. 2 divided by 1 and -2 divided by 1. 4 divided by 1 and -4 divided by 1. Got those. Now we're going to go back through the 3's. 1 divided by 3 and -1 divided by 3. 2 divided by 3 and -2 divided by 3. 4 divided by 3 and -4 divided by 3. All right, so 1, 2. So we have 2, 4, 6, 8, 10, 12. We have 12 choices here. Let's try to find out where do we see these. This is looking pretty good. Let me just make sure. I have 1, 2, and 4, both positive, negative, 1/3, 2/3, and 4/3. Correct answer is B as in boy. Let's look at number 8 on the front side. Again, no graphing calculators are being used. What is the graph of the following polynomial equation? So I'm going to start by writing this down. X squared minus 2, or x cubed minus 2x squared minus 4x plus 8. Now, if I could figure out what are the solutions or the x-intercepts, I think I could look at this graph and I could kind of figure out which one it is. I also noticed, by the way, before I do that, before I dive into the x-intercepts, I noticed that this particular polynomial equation is odd. So I have an odd degree, and the number in front is a hidden 1, but it's positive and positive leading coefficient. And I know that odd degree with a positive leading coefficient is up on the right and down on the left. So let's see what I can eliminate before I even look at the roots or solutions, x-intercepts. So up on the right, down on the left. Not this. Oh, here's up on the right, down on the left. It could be this one. This is not up on the right, down on the left. This is not. There's only one choice. I don't even need to dive into what are the solutions. I could just use the idea of end behavior in order to choose the correct answer. Let's try the same thing on the back side with number 9. So when we look at number 9, I'm looking at, now before I even look at the roots, the x-intercepts, these are all different terms, the solutions. Let's look at, we have an even degree, so even degree, and the leading coefficient is positive leading coefficient because in front of this is a 1, a positive 1. So even degree, positive leading coefficient. Give me 1 second. Since I'm on the phone right now, sweetie. Go find Benny. I don't know where he is. Okay, so that is up on the right and up on the left. That's not the case. Okay, it could be this one. It could be, okay, so now I have 2 choices and I have to decide which one is it. What do I do next? Well, I'm going to teach you, you're not going to get multiple choice options. Let me actually go ahead and teach you mathematically what you're going to do. I'm going to figure out what are the solutions. So when I want to figure out the x-intercepts or the solutions, I'm going to set y equal to 0. All x-intercepts have a y value of 0. 0 equals x to the 4th minus x to the 1st minus 6x squared. And I recognize I can factor out an x squared. And I'm left with x squared minus 1x minus 6. And let's see if I can factor this. What multiplies to equal -6 and combines to -1? -3, +2. Yep, that works. X minus 3, x plus 2, and here's an x squared. So I'm going to take each one of these factors and I'm going to set it equal to 0. X squared equals 0. Well, the square root of 0 is just 0, and there's no such thing as plus or minus 0 because 0 is neutral, but I do know that I'm going to have 2 solutions. So x equals 0 and x equals 0. Here, x minus 3, I set it equal to 0. I add 3 to both sides, and I get x equals 3. Lastly, x plus 2, I subtract 2, and I get x equals -2. So at 0, it wants to bounce off, but at 3 and -2, it should just slash through because there's only 1. Here's a duplicate. Let's look at my choices. At 0, it does not bounce off. Here, it bounces off, and it slashes through at 3 and -2. Correct choice as C. Find the sum of the roots. So finding the sum of the roots means let's find the roots, also known as the solutions of the x-intercept, and sum means let's just add up the values. So I'm going to start by taking this quantity and I'm going to set it equal to 0. Now, we could go through and we could write down the possible rational roots, and I may need to do that because I don't know that I can factor this as is. Let's try. If I take out an x squared, I'd be left with x minus 2. Let's make sure x cubed minus 2x squared. I write minus x minus 2. What times x is negative 5x? Negative 5. Okay, that works. But negative 5 times negative 2 is not 6. That means I can't try to solve this using the grouping method. So what am I going to do? I'm going to go back where we're going to list the possible rational roots. So what goes into 6? Plus or minus 1, 2, 3, and 6. And what are the factors of 1? Only 1. Well, this would be pretty. So I'm going to test 1 and negative 1, 2, negative 2, 3, negative 3, and 6, and negative 6. Let's find out what works. So I'm going to start with 1. And I can see everything is here. So we have x to the third, negative 2x squared, minus 5x, plus 6. Everything is accounted for. 1x cubed minus 2x squared minus 5x plus 6. Let's see if I get a remainder of 0. Multiply, add down. Multiply, add down. Multiply. Oh, I was lucky. I just tried one. It works. What does that mean? I know x equals 1 is one of the 3 solutions. So I'm going to take the remainder. I have 0 equals no x's, 1x, and 2x's, and I'm going to now solve this. I'm going to try the factoring method because that's the easiest, but if it doesn't work, I'll use the quadratic formula. What multiplies to equal negative 6 and combines to equal negative 1, negative 3, and positive 2? X minus 3 and x plus 2. I'm going to set each one of these factors equal to 0, and I'm going to solve. So when I add 3 to the opposite side, I get x equals 3. I subtract 2, I get x equals negative 2. I had 3 solutions. One is 1, the other is 3, and the last one is negative 2, negative 2. And it says here to find the sum of them. So 1 plus 3 is 4, and 4 plus negative 2 is 2. Correct answer is 2, option D. Let's look at the same concept, but right now I'm going to find the product of the roots, the product of the roots. Okay, so I'm going to start right now by looking at it, and I'm always going to check, just like I did on the last problem, is it possible for me to factor this? Let's try. I can take out of the first two, I can take out an x squared. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. And I write this down, and let's see if there's that magical number that allows me to solve this using the grouping method. What times x is negative 3x? Negative 3. So negative 3x, and oh, this works. I get negative 3x and positive 12. So I can solve this using the grouping method. That works. What do I do next? My goal is to solve here. Well, it says to find the product. So let's go ahead here and set each of these equal to 0. And I'm going to solve. So I'm going to add 4 to the opposite side. X equals 4 is one of the 3. I'm going to add 3 to the opposite side. Then I take the square root. That tells me I have 2 answers. So I have positive square root of 3 and I have a negative square root of 3. And now it says take these 3 different solutions and find the product or multiply them. So I want to take 4 times the square root of 3 times the negative square root of 3. Okay, so let's just do these first. These will be the easiest ones to work with. Positive 1 times negative 1 is negative 1. And the square root of 3 times the square root of 3 is the square root of 9. Now, we know the square root of 9 is simply 3. So when I multiply these, I end up with simply negative 3. And then I'm going to take negative 3 times 4 to get negative 12. Correct answer is B. Which polynomial? Let's take a look at number 12. For number 12, we are going to do the following. For number 12, I'm going to write this in the form x subtract, and then I'm going to drop in what one of the zeros are, and x subtract, and I'll drop in what one of the zeros are. So I'm provided with 1/2 and 2/3. Now, 1/2 can't be reduced, and 2/3 can't be reduced. So what I'm going to do is it's called bottoms up. I'm going to take whatever the bottom is, I'm going to push it up. Take the bottom, not the larger number, the smaller number, the bottom number of the fraction, and push it up in front. So 2x minus 1 and 3x minus 2. And now I'm just going to go ahead and I'm going to FOIL. So I'm going to take front, outside, inside, and last. And when I combine like terms, this is what I end up with. 6x squared minus 7x plus 2. Correct answer is A. It's going to resemble number 1. And so we're going to write this equation in vertex form. So I'm going to start, but I'm just going to use the term y. So y equals 2x squared minus 8x plus 3. And I'm going to take the constant and move it to the opposite side. So opposite of adding 3 is subtracting. Y minus 3 equals 2x squared minus 8x, and now I have this blank spot. Whenever the leading coefficient is anything other than positive 1, I need to factor it out. 2 divided by 2 is 1. Negative 8 divided by 2 is negative 4. Now we want to factor this in such a way, and you're going to see it, and so there's a shortcut to doing this. There's a shortcut. The shortcut is take whatever that b value is. In this case, it's a negative 4. Give me 1 second here. It's a negative 4, and I'm going to take negative 4, so include the symbol, always divide it by 2 and square it. Negative 4 divided by 2 is negative 2, but negative 2 times negative 2, or negative 2 squared, is a positive 4. Oh, positive 4. Now, we did not just add 4 to the right-hand side. Notice 2 times 1 is 2, 2 times negative 4 is negative 8, 2 times 4. We added 8 to the right-hand side, and we must keep the equation on the left and the right side equal or balanced. If I added 8 to the right, I must add 8 to the left. So y plus 5 when I combine like terms. And now here's the shortcut. We're going to take this and rewrite it. So I bring down the subtraction sign. 4 divided by 2 is 2. And in front, I just put an x. Not an x squared, just an x. To write this in vertex form, I'm going to move the 5 to the opposite side, in this case by subtracting. Y equals 2 times x minus 2 quantity squared, subtract 5. If I graphed this, it would be the same thing as graphing this equation right here. Exact same thing. This is standard form, and this is vertex form. We're going to identify the vertex. So the vertex, oh, got the wrong one here. Let me find, where are we? I think this is it. Yep, this is it. Okay, where is the vertex? So the vertex, let me move this back down, sorry. The vertex here can be achieved. So the vertex of this, it's opposite of the inside, so positive 2 and the same as the back number. That is the vertex. That is going to be part B. What is the y-intercept? Well, in standard form, it's this number with no x. So the y-intercept is going to be 0, 3. And what are the x-intercepts? So whenever we achieve x-intercepts, y is always 0. So I'm going to take this equation right now, and I'm going to replace y with 0, and I'm going to solve. If you prefer to use the quadratic formula, then come up to this problem and use the quadratic formula. It's totally up to you. In fact, I already know I think I'd prefer to use the quadratic formula for this particular one, but let's keep going. So I'm going to add 5 to both sides. I'm going to divide by 2. And I have 5 halves equals x minus 2 squared. I'm going to take the square root. Now this means I'm going to have two answers. So plus or minus the square root of 5 over the square root of 2 equals x minus 2. And then I'm going to add 2 to the opposite side so that I have solved for x. So 2 plus or minus the square root of 5 over the square root of 2. Now mathematically this is right, but at this level you need to understand at this level that this is not in proper form. We don't want to leave a final answer with a radical in the denominator. So we're going to rationalize the denominator. What does that mean? It means we're going to take the square root of 2 times the top and the bottom. So I have 2 plus or minus, pi times 2 is 10. 2 times 2 is 4. And you're thinking, how does that help? You still have a square root. Well, now I'm able to simplify. I know the square root of 4 is 2, and I'm able to leave it like this. Those are the two x-intercepts for this problem. Look at our final one. So number 14. Number 14, we're asked to sketch a graph of this. So y equals x cubed minus 2x squared minus 8x. Well, let's just take a look at this. I can see I have an odd degree, and the leading coefficient is positive. That means it's up on the right and down on the left. Keep that in mind. Okay, let's look at the actual roots now. I can factor out an x out of all the terms, and I'm left with x squared minus 2x minus 8. I'm going to factor this portion, the trinomial. what multiplies to equal -8 and combines to -2. 4 and 2, they have to be different signs with the larger number being negative. So x minus 4 and x plus 2. And I'm going to set each one of these factors equal to 0 in order to find the solutions, the roots, the x-intercepts, all interchangeable words. So x equals 0, x minus 4 equals 0, and x plus 2 equals 0. And then I solve. So one root is at 0, one is at positive 4, and one is at -2. Now notice that each one of these has only been shown once. So they're all just a single root, which means it's just going to slice through the x-axis at those values. So at 0, at -2, and at positive 4, it slices through. It's going to be up on the right, down on the left, and then it slices through. So it's looking something like this.